All right, so now for our example, we're going to be taking data from the GCSEMV dataset, which is in the multi-level model package, so MLMR Rev package. And this is data that discusses student achievement in the UK. There are 1,900 about students from 73 schools, and we're going to be looking at their exam scores on a specific subject. So you can imagine, right, that there is a hierarchical or nested data structure here in which there are schools. So we have a variable for the school identifier. There are individual students within those schools, and we have individual information about students. So we know whether or not the student identified as male or female. And our outcome of interest, again, is going to be at the individual level, which is the total score of a student within a school. So we're importing the data here, and we want to walk through and consider each of the different pooling strategies for our variance. We're going to start off with the most simple model that we are accustomed to talking about. And again, remember that we're indexing I here for each student. So it's going to be 1 through n, which is around 1,900. I'm going to briefly introduce some new notation that we are specifically using for the multi-level context. Now, this is something that we could use in the simple context, and so that's why I want to talk about that first. So all we're saying here is that for each individual observation that is normally distributed, right? So each of our yi's is drawn from a random variable that has a normal distribution with mean that is equal to our intercept plus the relationship between our covariate and our outcome. So this is exactly what is happening when we look at where our our fitted line goes through, right? These are conditional means. So this is what this is saying, is that our conditional mean is going to be determined based on our regression line, which is exactly what we were doing before. Then the second part is just saying that the variance around that is going to be sigma squared, which is exactly what we had before. So when we run this in R, this should look very familiar. We are going to be using the LM function. Course is going to be our outcome, and our main predictor at the individual level is going to be female, male or female. So we run our regression model. This is our complete pooling model, again, because we are not differentiating between schools here or students. We do not care, and we are not modeling that variance with this model. And we can see here that our estimated coefficient between the relationship of female and the course grade is positively related, such that a unit increase in our gender variable, so going from male to female, equates with approximately 5.8 better